Hello and welcome to Learn Synthesis with Pure Data, Season 1, Episode number 4. And in this lesson, we're going to learn additive synthesis and how to use it to make the 4 basic wave shapes. Basically going to take sine waves and make our 4 basic wave shapes with just sine waves. And away we go. I just want to say a few things now before I get started, just to get them out of the way. But if you're finding this series to be useful, or any of these episodes to be helpful for you, please do hit the like button. It helps me out a lot. And subscribe if you want to see more content like this, or to be notified when a new video is released. I need all the help I can since I've started this channel over and starting my synthesis tutorials all over again, trying to bring them to a higher level of quality. It's been slow going in regaining subscribers because a lot of people don't know I'm here on a different channel now. So please help me out any way you can. Share the videos on social media and so forth. So anyway, let's get to the lesson. Got to get some screenage out of the way here, and then bring you to my desktop. Okay, so I've been saving everything in a folder. And I think window, I should be able to go here. Zoom in to see what I'm looking at here and load up. Oh yes, I was correcting some assignments. So I'm just going to go to File and open it directly. Okay, so learn synthesis for data. Now, first thing I'm going to do is take this synth patch, and for my organizational purposes, I'm going to save it to a subfolder called Episode 4. So I save all of what I accomplished by the end of each episode will be saved. I do not put these on my website, however, because I think the best way to learn is to do it yourself. But just by saving as into that new folder, oh, it wants me to give it a name. Usually it leaves it there. Okay, there we go. Synth is what I'm calling it. Now, synth, as you would remember from the last episode, refers to this patch, which is the parent patch. This is going to be our overall synthesizer. That's why I'm calling it synth. And what we made last time was just to see how to use wave shaping to make the 4 basic wave shapes. But ultimately, what we're going to do is use this multi-oscillator that we made last time as a amplitude modulating oscillator, which is a lesson that's coming up in the future, not too long from now. But so we're not going to use this just yet, but this is where you can see how by using math you can create the 4 basic wave shapes: sine, triangle, pulse wave, in this case we made a square wave, and the sawtooth wave. So now what I'm going to do, just so that each time I open this I don't have to go up to the media menu and turn DSP on, sure you all remember this from previous patches, I'm just going to make an object called load bang, and then I'm going to Click it so that I can just make a message and it'll hook it up automatically. Control 2, Command 2 in Mac. Semicolon. You got to remember to hit enter. Even though it doesn't go to the next line yet, as soon as you type it does. ED, ESP, space 1. That way it'll turn on digital signal processing every time this patch opens. In fact, if I go into run mode, hitting Control E to do that, Command E in Mac, hit that, and you'll see it's running. And if we did check it last time, but just to double check, see as I click that, that was actually the third selection, a square wave, one of the pulse wave family. And then we have the triangle wave there in the second option, and sawtooth as the fourth option. So anyway, what we're going to do is make something like this, except in a different way. I'm going to right click on this and go to open, and it shows me the subpatch. We're going to make a new subpatch today for what will be a signal generating oscillator, and we'll use it that way in the synth. But we're going to make these wave shapes in a different way. So you can see how you can create different wave shapes by just using sine tones. Now, one thing I want you to do, if you haven't already, to hear these last time, I hooked up a DAC down here, but you'll want to get rid of that because this is not going to be used in the future for sound. So no DAC. Just these things that you see in front of you, which was where we ended up last time. Now I opened this so I can see by right-clicking in space and going to properties, what is the size of this graph on parent window that shows things, because the next one is going to be about the same size, a little bigger, but about the same size. So I wanted to see what I used. 170 by 240. I think I'm going to make the next one 170 by 260 because it's going to have some more things in it eventually. And then this table is what size? When you go to its properties, you can see its size right down here. Horizontally 150, vertically 150. It's square. That's fine. I'll use that again. All right, so zoom back out, close this up. Now we're going to make another subpatch, and we're going to give it a distinct name. This one was named amp mod, and that's it, amplitude modulation. So what we're going to do with this one is make an object, type PD space, and we're going to give it a unique name. Here I'm going to call it OSC_1. That means it's going to be the first oscillator. This window opened up here. This window is the child patch, and it's basically the inside of this object that we made here, which is a subpatch or a child patch. You can think of it either way. I'm going to give it more space so we have room to work. And first thing I'm going to do is, before I forget the numbers, right click on the background, go to properties, and I'm going to make it graph on parent. And I am going to make it size, see, 170 wide and 260 tall, giving me a little extra space in the other one because this one will have a little bit more than the other. Okay, I can always resize it if I need to. I was just thinking about that. Now we're going to make the array for this oscillator. Control-Shift-A, Command-Shift-A in Mac. And we need to give the array a unique name. I'm going to call it OSC_1. and then another underscore, and I'm going to say here wave at the end. So it's OSC1 wave with underscores in between. And right from the start, I'm going to make a Bezier curve because I like the look of that display better. Okay. Now, it didn't give... Oop, I drew on it because I'm in run mode. That'll disappear shortly. Got to go into edit mode, move it down. Now let's make it the right size by right-clicking on the table, going to Properties. We get the initial properties window that we got when we created it. I'm not going to do anything there just yet. And what I'm going to do here, make it size 150 by 150. Nice little square. I mean, this is just its display size, so this doesn't affect any of the patchwork that we're going to do other than having this table fit in here the way I would like it to. Now I'm going to save, and I'm going to hit Control W, Command W, and Mac just to close this window, not the overall patch. I want to look here. Moment. And see what I named this guy, because I'm going to make another one. I called it SH amp. Oh, that's a label. That's not its actual name. Let me go in and look at it. I'm going to open up this subpatch and look at this shape. I can use that as the label for the next one as well. Because remember, the labels are not things that PD communicates with, so you can name things freely there. But here, I have sends and receives. This is amp mod wave send and amp mod wave receive. So I want to keep the same kind of naming system, but different names. So let's open this subpatch again. And we're going to make one of those radio button things. Under put, it's H radio. Right here. I'm going to put it up right about here. I'm leaving space for the name of this subpatch to display up here on the parent patch. I'm going to right click on it, go to properties. I'm also going to say shape here. And it's going to have 4 options again because we're going to have 4 basic wave shapes. So I'm changing the value there to 4. Size I'll keep the same because I think I used that in the last one. Now, since this is associated with the oscillator 1 wave, I'm going to name it OSC underscore 1 underscore wave underscore send. So its send symbol will be that, so we can receive information from it elsewhere. Now, I don't think I'm even using this, but I'm going to give it a receive symbol anyway. Wave underscore RECV. That's just my style. Instead of the whole word receive, I go REC. So there you go. Those are the send and receive symbols for this. So we can select shapes with this. All right, good. Next. One other thing in setting this up, I'm going to save it. Control W to close this window. Right click, go to open. I'm just going to copy this guy over, the on off switch. I'm going to hit Control C, Command C in Mac. Just copy it. Open this window up. And then Control V to paste, Command V in Mac. Yeah, and it looks like it's basically where it should be. There we go. Because we'll want to be able to turn this on and off as well. Or actually, I just thought of something. This isn't going to have an on-off switch. Delete it. Sorry if I wasted a minute of your time there. Okay, now what we're going to use here to make this is we're going to basically put wave shapes into this table and use this table as an oscillator. I'll show you how that's done. We're going to make an object called tab OSC tilde. Sorry, tab OSC 4, number 4 tilde. There is an object tab OSC tilde, but the tab OSC 4 tilde object works a little bit better. And then I'm going to put in the name of the table that it's going to oscillate. Basically, this is an object that oscillates tables and sends its signal out here. Now, what do we want to oscillate though? I mean, technically it will oscillate this. It was a weird sounding, you know, mistakenly drawn wave shape that I put in there. Let's do something. I'm going to turn off DSP with the shortcut, Control period, Command period in Mac. I'm going to hook up a DAC. And then I'll turn DSP on and we'll hear it. I set my levels beforehand, so hopefully this won't be too loud. But just to show you, we can hear this. Let me check here on its help file. Because I want to see phase. Okay, so it looks like its next creation argument will be phase. So you got to actually send it a frequency to have it actually sound through its left inlet. Here they do it by letting you type in a frequency here, converting that to a signal, and then putting it right in. You don't even have to convert it to a signal. It's just to show you it will take audio rate frequency values, which is good. And then I'm looking over here because we're going to do this stuff here. Okay, table name, assign some, and then, yeah, okay. I was just reminding myself of the order there. Okay, but for now, I could just make a number. How about a message? 440 to send in here so that we will get signal. Now what I'm going to do is go into run mode. I'm going to turn DSP on. I'm not hearing anything yet because this did not get frequency yet. But if I click this, I'm looking here. I have a typo. OSC_1 wave. No, not doing it. Probably because this wave shape. Let me double check something here. DSP is on. Let me test my audio and MIDI. Now this is designed not to use wave shapes like that. Okay, yeah, so we do hear sound there. We're not hearing it here. Oh, let me see here. Oh, it's 100 size and everything. Yeah, we're breaking the rules. We're breaking the rules. Okay, let me show you the rules. I'm going to make a message that is going to give this table a wave shape that will work. Tab OSC4 needs specific wave shapes. Well, not specific ones, but their size is important, and I'm going to tell you about that now. So I made a semicolon in this message box, hit enter, and I'm going to type table name OSC_1_wave space. Now you got to tell it a size of the table. And the size that we put here is also got to be the size of the table. But from what I remember, this message will make the table that size. Now this is not a display size, so it's not going to get bigger or anything. This is the size as the number of values that make up the wave shape in this table. And it needs to be a power of 2, meaning 2 with an exponent above it. For example, 2 to the 1 power equals 2, because it's 2 1 times. 2 squared, or 2 to the power of 2, equals 4. 2 times 2. And for the powers of 2, you could keep doubling numbers. 2, 4, 8, 16, 32, 64, and keep going. Now, the size that you need is going to depend on how many harmonics we're going to tell it to have afterwards. Oh, that reminds me, what I need to put next before the size is actually the command that we're using to write to this table, which is sine sum. This is going to add together sine waves. And what we're going to do next is put in our size, which, as I was saying, needs to be a value that will contain the number of harmonics that we're going to use. Because what we're going to do is take all these harmonics, add them together, and each harmonic will be a sine wave, but it'll create a different wave shape based on their harmonic strength. I'm going to type 1024. That's a good value for, like, let's say about 12 harmonics, which is about how many we'll do. And as we go on, we'll see about adding more and more harmonics. 1024. And now the next thing we need is a value that says, what is the strength of the first harmonic? We're going to say 1, full strength, then put another semicolon. Look outside the message box, go into run mode, and I'm going to hit this message. There we go. It works. Now I turned off DSP by hitting Control period, Command period in Mac. Got to get those shortcuts down. Control / and Command period are for turning on and off DSP respectively. In Mac, of course, you substitute Command instead of Control. Command / turns on, Command period turns off DSP. So on the fly, you can turn it on and off. So there we go. We see a nice smooth sine wave. The reason being is our first harmonic is full strength, and it is a sine wave because this is a sine sum command. Sum meaning to add. So we're adding sine waves together based on the order here of harmonics and how strong they are. Sine wave, if you remember from earlier lessons, is one harmonic, called the fundamental, the pitch you hear, and no other harmonic content. So this is how we made a sine wave, which is also incidentally the first wave shape that we want to have. We want to be able to use wave. So there we go. Now we can use this sine sum command, add together sine waves at different frequencies, the frequencies that are the harmonics in order, and they will be at a strength that we define. And this is how we do it. Going back to edit mode, I'm going to make another message. Control 2, Command 2 in Mac, semicolon, hit enter, start typing OSC _1 _wave space sine sum space. We're going to use the same value of 1024 space. Our fundamental is going to be full strength. And then our next harmonic is harmonic 2. Now I'm going to start making a sawtooth wave next, just to kind of get this concept down, because a sawtooth wave shape does have every harmonic included. The other wave shapes don't include all harmonics, but the sawtooth does. And there's a formula for what their strength should be. It is the harmonic number divided by no, it is basically it is the strength divided by the harmonic number. And I'm just seeing here, I did this again. Must have had the shift key down when I hit that. OSC1 wave. Sine sum, 1024, 1. Because it's the first harmonic and 1 over 1 is 1. Now, the next harmonic, what we need to do is take 1 and divide it by 2, because it's harmonic number 2. But you don't put fractions in PD in here. You would put decimal points. So you literally divide 1 by 2, and what you get is 0.5. Instead of typing 1/2 for 1/2, you need to type 0.5. Now next is 1 over 3. Now 1 divided by 3 gives us 0.33333, and it keeps going. It's one of those repeating divisions. 1 doesn't divide by 3 evenly. It's 0.33333, and it continues forever. So I put in 5. That should be accurate enough for our purposes. So I just put in 0.33333. Okay, next. This is the fourth harmonic. That's 1 divided by 4, which is even enough, 0.25, 1/4. The next one is 5, so that's 1 divided by 5, 0.2. The next one is 6. 1 divided by 6 equals, let's see, 1, 6, 6, and the 6's continue. And they would continue forever just like the 3's there. But 1, 6, 6, I'm going to put a 7 here, because I do not want 666 there. Personal preference. It's rounded up from the next value anyway, so I'm putting 1.667. So anyway, next, 1 divided by 7, 0.142. Let me see here. I'm trying to do it in my head. 1, 4, 2, 8. There, I think that's it. .428. Let me see here. Let me do it again in my head. 4, 2, 8. No, it doesn't stop there. 5. And this is going to keep repeating. 7. So it's going to keep going on. I'll just go that far. Now I can take the end of this message box and extend it to the right so that no one gets confused. That is supposed to be all one number. 0.14287. Now why did I go more decimal places this time? Well, the more decimal places you go, the more accurate it is. So maybe I should be consistent and go the same amount of decimal places. Here I have 5 3's. And this is only for these things that are continuous. 0.16 Oh, that's supposed to be 1.667. The whole thing is I don't want 3 6s in a row. Well, I guess I can put a 7 at the end. That'll negate it. All right. And then here, 1, 4, 2, 8, 5, 7. How many digits is that? 1, 4, 8, 2, 5. Let's get rid of the 7. But since 7 is above 5, we can round this up to 6. Base. Okay, there we go. Next is 1 over 8. 0.125. That one doesn't keep continuing, so we don't need to keep going over decimal places. Now, next is 1 over 9. 0.1, and this is continuous. 1, 1, 1, 1, and then I'm going to put 1 there as the 5th one and leave it at that. Okay, I'm not rounding up, it would be rounding down in that case. So any case, we have up to that. Then at 0.1, that's 1 over 10. Now we're on our 11th harmonic. Now I'm going to start using a calculator. Zoom out here. Calculator. 1 divided by 11. Now I'm just going to go 5 digits beyond the decimal. 0.090909. 0909, and I'll just put 1, rounding up. 0.09091. Okay, next is 1 divided by 12. I shouldn't have closed the calculator. And 12 should be enough for us to see what I'd like you to see. 0.083330, and it continues with 3s. Zero 0.08333. Now I'm going to put a semicolon for the end of that line. Look outside the message box, go into run mode. Now I'm going to click this message, and it gave us this wave shape. As you see, it's kind of like sawtooth, but bumpy. That's because of all these sine tones being added to it to make the shape. The more harmonics we add, the more these bumps will get smaller and smaller and smaller and closer to the sawtooth-shaped diagonal line. But I don't need to add more. But one thing that is an issue is you see how it's exploding out of the table. Now, a way of dealing with this is the following. I'm going to change something here. This is not going to be our display table. This is going to be our shape table. Now, I'm going to right click on it and go to its properties. And it's called OSC1 wave. I'm just going to add the word shape to the end. Wave shape. Means I need to rename it here too. And in this message. Both of these messages are communicating with that table. Now the table that's going to display what actually is getting played, I'm going to make here. So I'm going to make another array. Control-Shift-A. And it takes me right to this window here, and I'm going to name this one OSC_1_wave. We can do this now because we renamed the other one to wave shape. Make it a Bezier curve. Press OK. Now where to put it? Right up here. Now we're going to resize it. Go to its properties, move this aside, and its size here is going to be 150 by 150. So it fits in that box. Okay, there we go. Now what we're going to do is this. Disconnect these cables. When you hover over them, it puts the X there so you can press delete or backspace. Get rid of them. And we're going to make another tab right to display our waveform. Tab, WRITE, tilde, space, OSC_1_wave. Because we want it to display this table. Or, yeah, we want this table to display what's coming out of here. But now, since this is exploding out of the top, we're going to shrink it down. And I'm going to see here how much by. We're going to basically multiply it, star with a tilde, because this is audio rate, an audio signal. Let's multiply it by 0.7 and see what we get from that. Then that's going to feed into here. And that's where we're going to need Metro. Bang this continuously. And now I just remembered, yes, we do need that on-off toggle for Metro. Metro 100, that means every 100 milliseconds, 10 times a second, it will bang this. But we want to be able to turn this display on and off. So we need that toggle that I deleted earlier. Sorry. Bit of a brain fart. So we're going to just save this, close it. Right click on this subpatch, open it. Select the on-off switch, hit Control-C, Command-C in Mac. Right click on this subpatch, open, and then Control-V, Command-V in Mac. And we have our on-off switch right here, our toggle. That's just quicker than making it again and trying to get the on-off label to line up like we did last week. All right, there we go. Now, we could just, I don't need to disconnect it. I don't need to connect the DAC. I could just turn this on. Hit that. And now, oh, I connected this to the wrong thing. On-off connects tab right. I mean to Metro, to turn Metro on and off. But we do need a message here to give a frequency to tab oscillate. Let's do that. Punch it in. Make sure Metro's on. We must have an issue. Calculator out of the way, see if there's any errors. Yeah, this is from earlier when I was trying to send signal to it and it didn't have the right kind of wave shape. Oh, I see. Tab oscillator 4 is still oscillating this new table rather than this one because we renamed this wave shape. So we need to type here shape. tab right tilde OSC1 underscore wave. Wait a minute. No, no typos. See, do we have any errors here? Last messages when I saved it. Saved again. Yep. Let me see what's wrong. Okay. Follow the signal. 440 going to tab oscillator 4. Telling it to oscillate OSC underscore 1 underscore wave shape. Over here we have OSC underscore 1 underscore wave shape. And it does have a shape in it. Next signal goes to star tilde space 0.7. Now that attenuates it. That reduces its amplitude, but not enough to make it zero out. And then that goes into tab right tilde OSC underscore 1 underscore wave. One thing is I may have DSP turned off, so let me try that. Control /. There we go. Yeah, I had DSP off. So you see it's still breaking out of there. Let's try 0.6. And I'll show you why it's breaking out of there in just a moment. Okay, now it's not. But still, make it 0.5. There we go. That's definitely not breaking out of it. Let's hear it. Put the DAC here. Connect these up. You're going to hear it suddenly turn on. One side. And the other. There, I turned off DSP. All right. So, as you see, it sounds much more nasally than change shapes and do this. Then a sine wave. Now, this is something I'm going to do. The sine wave doesn't need to be attenuated that much. So we're going to make multiple tab oscillators. I'm going to yeah, let's disconnect the DAC for now. Move this down. And I'm going to take this and duplicate it. .5 is going to be for the sawtooth. And then take this out for the sine wave. So the sine wave does not need to be reduced in half amplitude. Like the sawtooth. Now, what I'm going to be doing is just like last time, where we have to turn these on and off. I'm going to have to do that again. So we do need, actually, took the time to straighten that. We do need in here those on-off switches that we had last time. Star tilde. Connect the signal line through here to here. And remember last time what we did is we made receives receive, sine underscore on off. And remember, we did some other patching. We wanted to make sure it went through a line tilde object that told it to go to whatever number, 1 or 0. We abbreviate that as F for float, and 50 milliseconds. And then we make a line tilde object. Remember, this is so that when it turns on and off, it doesn't make a snapping sound. The line tilde will slope it to the next value. This is review from last time. That's why I'm not explaining it in full detail, because we've done this before. Now I am going to select this and duplicate it just to save time in making a whole new one. I'm going to connect this to here this time. And then instead of sine on off, this is going to be called saw on off. And this will be connected down here to our Metro, eventually to our DAC as well. Actually, might as well hook them up. And just so they don't come out one side, I'm hooking it up to both sides. I need to hook this up to both sides. Well, left, oops, missed. Left, right. So now we need to include that in these messages. That first line is going to be first in the message. So the table here, the wave shape table, gets updated first. And then we're going to say sine on off space 1 semicolon. Saw underscore on off space 0 semicolon. That way the sawtooth waveform gets turned off. Now I had an extra space in here. I'm getting rid of that. Gotta be careful with these message boxes. Spaces mean things. Now let's try it. I'm going to turn on DSP. We're not hearing anything. Turn it off. Now I need to do this one. So after this semicolon, it treats that whole message as one line. The semicolons are kind of like line breaks that say this is one message, and the next message is sine underscore on off space 0 semicolon. Saw underscore on off space 1 semicolon. Turn the sawtooth on and the sine off. Gotta turn on DSP. Exploding out of the table. Let me see why. Receive, sine on off. Receive, saw on off. This should be on with the 0.5 coming through. This should be off. Double check here. In my message, sine underscore on off space 0. Sine on off, no such object. SINE underscore. That's the problem. I didn't name it sine underscore on off. I named it sine underscore off. Good that I make some mistakes so that way you can see them, as you'll encounter these things yourself. All right, I turned DSP on. .440 never got sent to the tab oscillator, so I had to hit that. Now, I'm remembering these are some things that, you know, if you want this to work from the beginning, you got to put a load bang and actually have them work. So I'm going to zoom out and start arranging things, because we have two more wave shapes to make, but they'll be about as wide as these. So I'm going to make it like that. Give us more space to the side, because I'm going to put our messages and our wave shape to the side. Now, we're also going to use this thing here, the horizontal radio selector, to basically select what wave shape we want. So we need to set that up. And this is going to be the same way we did it last time. We need to receive from it. Oops. There we go. I zoom in a little bit. Remember, if you see two mouse cursors, the big one is the one that I'm actually using. Kind of like a glitch with my magnifier and OBS, which is how I'm recording this. So I'm going to make a receive object, R space. Now what was the name of that? OSC underscore 1 underscore wave underscore send. So when you select something here, it uses its send symbol that we set up here in properties. This send symbol. OSC underscore 1 underscore wave underscore send. Alrighty. And then when that gets received, we need to select which number was sent, either 0, 1, 2, or 3. 0, 1, 2, 3 with spaces. Remember, that gives us 5 outlets. This one's for 0. The first selection we want to be a sine wave. Now, just like the other multi-oscillator that we made last time, the second one I want to be triangle wave, the third one a square, and then finally this one here is going to be the sawtooth. Remember, when you make a select object, it makes the number of inlets for the number of creation arguments that you put here, plus 1. So the last one, the one all the way to the right, you don't use, because this just outputs any number that is not one of these. Oops, accidentally connected it up there. So the first one is 0. Second one is 1. Third one is 2. Fourth one is 3. And that's all the options that we have from that selector. So that's all we need to hook up. This can go nowhere. And remember, these outlets don't line up with the numbers. They're in the order of the numbers. All right, so now let's make one for a triangle wave. Well, what I'm going to do that is I'm going to copy the sawtooth wave. Well, actually, let's do the square wave first, and you'll see why. I'm going to copy this sawtooth wave, duplicate it, and we're going to make this square wave values, which are slightly different. Now, the reason why we've had to attenuate things The reason why we needed to multiply this by 0.5 to keep it in the table is all these strengths of the harmonics add up and they go above 1, well above 1. So in order for it to fit in the table, we need to attenuate it, multiply it by a value less than 1 to kind of get it smaller so its amplitude doesn't break out of the table. Because you add up these values, you know, that's what's happening. It's summarizing, or summing, not summarizing. It's summing the amplitudes of all those waveforms together at the frequencies that they're at. So, as a result, it goes outside of the table. That's why we need to reduce it and put it in. The square wave will do the same thing, but we'll make it up as we go. So, the difference between how a square wave can be made using these strengths of harmonics, the formula is the same, except the square wave only includes the odd number harmonics. It doesn't include the even ones. So what you need to do is not delete the even ones. You gotta leave them there because that's how it knows that this is harmonic 1, this is harmonic 2, harmonic 3 is their order. You just gotta give them a strength of 0. So I take out 0.5 and put a 0 in. This is harmonic 3, that's odd, that's included. Here's harmonic 4. Place that with a 0. Here's harmonic 5, that's odd. Here's harmonic 6. That's even, so I'm making that a 0. Here's harmonic 7. That's odd, include that. Here's harmonic 8. You need to make that a 0. Now see, it word wrapped it around. Oh, this is all part of harmonic 9. You got to be careful in typing these. But there needs to be a space between each one, and this whole word wrapping thing throw you off. So just to make sure I didn't make a mistake, I'm going to click at the side here in edit mode, expand it, and see that, okay, here's 7, here's 8 is a 0, 9 is 0.0001. 0.09091, yeah. And then here's 10. Thought we went up 12. Hold on. Let me do these again. First one, then a 0. 3, then a 0. 5, then a 0. 7, then a 0. 8, then a 0. Oh. No. Yeah, 8 was the 0. 9, then a 0. 10. No, that's 10 there. This is 11. And 12 will be a 0. Or I could just not include it. But just to keep these consistent, I'm going to make it a 0. Okay. Now I'm going to go into run mode and click it. So we can see up here, we kind of have a bumpy square wave. And it's slipping out a little bit. So I'm going to multiply it by 0.8. But now, we need to add our oscillator for it. I'm just going to copy this one and change it. Selected the whole thing, hit Control D, Command D in Mac. Now the square waves is going to be here. Triangle will be here. Now for the square wave, it's oscillating the same table. It's multiplying, I'm going to multiply it by 0.8. Doesn't need to be multiplied by as much Because it has fewer harmonics, therefore fewer harmonic strengths, its amplitude doesn't go up as much. Now, instead of calling it a square, I'm going to call it pulse here because we will add pulse width modulation, so it doesn't always have to be a square wave. So pulse on, off. And let's connect it up. First to tab right, then to the left and right inlets of DAC. Okay, good. Now, I like to put it in between these two, so I'm going to add to this message pulse underscore on off space 0, because that's to select the sine wave. This is to select the pulse wave, so I am going to put the third one here. And I need to add its message that turns it on. Pulse underscore on off space 0 semicolon. No, 1, because this is the message to turn it on. Means I need to put a 0 here for the saw to turn it off. And then down here, the message for the saw wave is going to be pulse on off space 0. Okay. Save. Now the thing is, before this will work, not only do I have to turn on DSP, but let's make sure the 440 is sent here. Okay. Turn on DSP. Sine. Square. Sawtooth. Okay. We're getting it. Oh, we're not. Look at this sine wave exploding outside. I made a mistake. Not everything's being turned off. And in fact, when I turned on the pulse wave, the square wave, ooh, what did I just hit? Control plus, which zoomed in way too much. Just need to zoom in this much. Ah, with the Windows key. There we go. All right, so for a sine, 1, 0, 0. Sine on off. Pulse. P-U-L-E. I spelled it wrong. Pulse on off. 0. Sine on off. 0. That could have been it. Making sure I don't have other typos. So let's hear it again and try it again. I'll turn on DSP. That's the sine wave. Pulse wave. Sawtooth. And they're all sounding pretty comparable in level. So that's good that I have these attenuations here. Ah, I did that again. Okay, zoom in this way. So now we got to make the triangle wave. And the triangle wave's formula is closest to square wave, but we're going to have to change some things. Not the same. But we'll copy the square wave message and put it in. But let's do this first. Let's just make its oscillator. selected it, Control D, and then remember to click on the blue highlighted stuff. That's the new stuff that was duplicated. Put over. Okay, it's going to oscillate the same table, except it's going to attenuate by, let's try 0.9. Because it has even less harmonic strength to it. And it's going to receive a message that we'll make called triangle on and off. Gotta make sure I type that right in the message box. We need to connect it to the DAC as well. Okie dokie. Now, lighten this up here. There we go. Okay, so I am going to select the pulse wave message. Hit Control D, Command D and Mac, grab it, move it up here. This is going to be our second option, so let's hook it up. Now we need to change this message in a few ways. The strengths for the harmonics of the triangle wave are, once again, you only have the odd number harmonics, but the values are 1 over the harmonic number squared instead of just 1 over the harmonic number. So instead of this being 1 over 3, it's 1 over 3 squared, which is 1 over 9. Now we do have the values for 1 over 9 right here, 0.11111. So zero 0.11111. As you do this, make sure you're doing it in the right spaces. This is harmonic 1, it's on 1. Harmonic 2 is off, it's 0. Harmonic 3 is 1 over 3 squared, same as 1 over 9, 0.11111. Harmonic 4 is 0. Harmonic 5 is not 1 over 5, but 1 over 5 squared. 1 over 25, which is 0.04. Okay, then 1 over 6, 0. Looks like I accidentally deleted that. So yeah, 1 over 6 is 0. Now 1 over 7 is 1 over 7 squared. The 7th harmonic needs to be 1 over 7 squared. Let's do the calculator. Because 7 squared is 49. Let's divide 1 divided by 49 equals 0.0204. Now since we're going 5 decimal places, this 8 will round this up to 1. 0.2041. Leave the calculator open. Let's see here. That's 1 over 5 squared, 0. Here's 7. 0. Actually here. 0.0. Oh my god, I forget already. 2041. Then this is harmonic 8, which is off at 0. Harmonic 9. This is 1 over 9 squared. I'm just going to delete the rest of the harmonic strengths here and just put them in so I don't get confused. 1 over 9 squared is 81, so 1 divided by 81. First of all, clear what's here. 1 divided by 81 equals 0.01234. Oh my God. But look, right here between 7 and 9, the 8 is skipped. 0.01234. That's as far as I need to go. Or I should round that 4 up to 5. 0.01235. Space 0. That's for 10. Now we're going to put in harmonic 11. 11 squared is 121. Right? Yep. So 1 divided by 121 equals 0.00826. 008. No, 6 is here. 0.00826. Just do that. And then harmonic strength 12 is a 0 because it's an even number. And that's as far as we're going. Now we could click this just to see what it looks like. Now it looks kind of sine wavy, but it is coming to a point. As you add more harmonics, it becomes more and more like a point. But for now, that's as close as it's going to get. Okay, so now we need to change the rest of these messages. This is for sine. Have it turn triangle off. Triangle underscore on off 0. Semicolon. Don't forget the semicolon. This is the actual triangle wave, so triangle underscore on off space 1 semicolon. I gotta change this to a 0 since we copied this from the pulse wave. Now here we gotta turn it off on this one. Triangle underscore on off underscore, not underscore, space 0. Then here, triangle underscore on off underscore, well, space 0 semicolon. All right, there we go. Now, in testing this, I'm also going to test it by using the radio selector for selecting the different waveforms. Another thing I need to do is, since we just duplicated it, 440 message never got sent here. In fact, what I'm going to do now, just so I don't forget to later, make an object, load bang. And basically when the patch opens, it's going to bang all these messages through. Because there needs to be a frequency value for tab oscillator in order for it to work. Eventually, as we build more components to the synthesizer, we'll take some of these things out. But right now, let's leave them in at this stage. So we have a working patch. And I'm sending a load bang to a 1 message, turn on the toggle that turns on metro so we see the waveform display. Okay. Now looks like I have here, I'm going to do a little cleanup real quick before we test this out. Take up a little less space. And you know, before I forget, what I'm going to do, I'm going to take a screenshot for the thumbnail of the video. Okay. I'll crop out the rest of the stuff. Here we go. There's my screen. Good. Now let's zoom in. I'm going to turn on DSP with Control/. Turned off DSP with Control. All right, and anytime I say Control, Mac users, just remember it's Command for you guys. Now I'm going to hit Control W to close this window. Down here in the taskbar, I should have the window for the main parent patch, and so we'll see the waveform display here. Now I'm going to test it. I hit save. If you save the patch with the subpatches open, it'll open up next time that way. So what I'm going to do is this. Open up PD again. And now the last project saved should be what I just made. I'll go here to File. Now I just turned off DSP by clicking it off there. The reason why we're seeing the sawtooth is because that was the last value in here. Let me show you. I'm right clicking, opening the child patch. It was the last thing in the tab oscillator. Why? You right click on the table and go to properties. You'll see on this thing here, there's an option here, save table contents. It'll save what values are in this table with the patch. We don't want that. We don't want the last stuff that we did to be in this table. We want it to start afresh the next time we start. But I'm going to have it start, just so that nothing's playing, I'm going to have it start as Sine. And the way to do that, since this radio selector is at 0 to begin with, as long as the load bangs it, it'll bang this 0 through, which will tell it to do the sine wave over here. Now, that being said, you see how this thing, the selector's on sine wave, but the table's showing a sawtooth? Because that's the last thing it was at. So this table should not be saving content. We have this load bang sending the selector to sine, but it didn't. Okay, let's try this. Let's at least go to its properties. And turn off save contents. There's one more thing I'm going to test here by opening it again. Save, close. Save again so that it opens with just these two displaying. I close this. I am going to keep the same PD window open. Open the file again. All right. Synth. Oh dearie me. Maybe this table, did I ever turn off its contents? No. But how come this one over here is on sawtooth? It's not saving contents. Okay, this is what we're going to do. We're going to make sure this radio box gets sent a 0. So instead of just hooking it up for a bang, I'm going to send it the message 0. So that it both start on sine wave. Because that's what the selector starts on. First position, which is value 0, which should be sine wave. Do the same thing over here. Make this look like the other one. Make a 0 message. Connect it up. Over here to the radio box. Okay, I'm saving, closing this, opening it up again. There we go. Weird. I don't know if you noticed that, but when I selected, now this is the one that's supposed to be sounding, but when I selected Sawtooth over here, I heard this get quieter. Oh, you know why? Look at this. You see how these receives have the same names as the messages over there. We got to change them. We got to change all these receives and the messages. Because when this is turning on and off things over here, it's also affecting the receives over there because they have the same names. Sine underscore on off, sine triangle underscore on off. Ooh-hoo. Trying to think, maybe instead of coming up with all these funky names, oh boy. Yeah, I'm gonna have to do it. I'm gonna try and do it a quick way. Amp underscore mod underscore. I'm gonna put that in front of all these receive names. Let's select it. Amp underscore mod underscore. Just that much. Control C, Command C in Mac. Since I'm going to put the same prefix on all these, I can paste it in. Control V, Command V in Mac. Got to be careful. Can't have any typos or paste it the wrong spot. Got to be exactly that. And then in these messages as well, which means I need to make this a little wider because the messages will get wider. And this will probably be the quick, I'm going to show you probably the quickest way to do this. Things have to have unique names or else this message is going to go to 2 places. Now, since I did this one, it's probably quicker to do this. Copy it down here. This is going to be the pulse wave. And then I'm just going to change the 1s and 0s. 0, 0, 1, 0. Quicker than changing the message names, I think. Actually, it probably took the same amount of time. Well, since I already did that, just keep doing it the same way. Here, this is going to be 0, 1. Turns the pulse wave on. And the other thing's off. And this one turns the sine on. And the other's off. Now, things will work at this point, because now that these sends and receives have different names, I can select whatever wave shape I want here and have it not affect the sound, because this is not affecting sound. What was affecting sound was its messages had the same names as the receive names on this one, so they were conflicting. But I don't want to leave these still just being sine, triangle, and so forth, because we're going to actually have 2 of these oscillators. I'm not going to make it today, but what we will do in the future, when we add some components to this, we're going to then duplicate it and rename things and have 2 oscillators that generate signal, so we can make more complex sounds that way with two oscillators. So what I'm going to do here, wrong zoom, is I'm going to give these unique names. OSC1 at the beginning, _1 _. Now let me select that bit so I can just copy and paste it. You just got to make sure you're only selecting OSC _1 _. And we can click here. So it's right in front of triangle. You make mistakes here, things won't work right. Got to be careful when you're copying and pasting. So we just need to put that in front of each of these lines here. It's good that, I make mistakes like that so that you can see them. So that when you're patching, you know of, how to error check, what types of things can go wrong, and how to fix them. You gotta have unique names for all the things that have symbol names. Otherwise, you'll be sending one message to 2 different places. And what was happening, the reason why I was hearing a change in level, was it was turning off the signal on one of the oscillators. It wasn't changing the wave shape, but the message was going straight to here. And so when I was selecting different wave shapes over there, it was changing which of these was coming through. It was still using the same wave shapes because these messages weren't affected, but it was taking the wave shape that was here and changing its volume because it was coming through different things here. So we need to take these receives and paste that OSC1 in front of these. Now we have unique names, and they make sense. Basically, all the send and receive names in this subpatch have the OSC _1 _ prefix to it. So everything within this subpatch has their unique names. I did it properly with this and this. So that's good. Now, the thing would be, one last time to open it up and make sure it works. You want to get in the habit of always at the end, when you think you're done, close it, open it again, and test it. All right, I'm turning off DSP, but I'll turn it right back on. The first thing I want to do, make sure that this amplitude oscillator here does the shapes it's supposed to do, but we won't hear any change. Now, when we do this oscillator here, we should hear the change. But it shouldn't affect this. Oh. Now make sure they both turn on and off. They turn on and off. There we go. So I've error checked this. It works. And we are done for week 4. Episode 4, that is. So, thank you for joining me. I hope that you've enjoyed or at least learned from this week's lesson. And, you know, if you are getting value out of the series, please do hit that like button. Subscribe to the series. I need as much promotion as I can, so I'm putting out the call there. Please help me out. Working hard here as a cottage industry. All right, until next time. Oh, yeah, what are we going to do next time? Well, I'll let it be a surprise. How about that? But we are going to go further in making this into a working synthesizer. But we're going to continue to learn our fundamentals by step. So I'll see you then.